Hey folks, good morning, good evening. Welcome to this session of AccelEdge. I'm Pradeep from the customer success team, and today we're diving into Hive with a focus on real world as well as field tested best practices. I'm joined today by Rohit, who is one of our product specialists. Rohit works closely with our engineering and field teams, helping customers get the most out of Hive at scale. Uh, if you can go to the next slide, yeah. A quick housekeeping before we jump in. If you've got any questions, you don't have to wait till the end. Just drop them in the Zoom chat, and we'll pick it up whenever possible so we can keep things interactive. Apart from that, if you'd like to keep the conversation going, you can always head over to our discussion forums on the Axel Data Network portal. So feel free to drop in your thoughts or question, and we'd love to keep the hive mind buzzing over there. So over to you, Rohit, for the session.
Okay, thanks, Pradeep. Thank you. Hi, guys. Myself, Rohit Rai Malhotra, and I'll be uh, going through this topic of Hive best practices today, where the focus would be on the real world scenarios and the practices that really help in optimization of the resources as well as getting the best throughput of any queries that we run. So these are the topics that we will be covering. The initial topic refers to the Hive query execution. So just so you know, we would be focusing on the Taze execution alone here because that is where most, or at least most of the execution or most of the usage for Hive is based out of based on Taze. So we'll be focusing on that alone, and so we'll understand how the query execution works, what are the components involved in the query execution based out of Hive service, based for like around Hive services, yarn based resources and all those things. Then we'll go to query resource management, where we'll understand how you can control the resources allocated to the to a query, Hive query running on Taze. Then again, as the topic suggests, Hive Yarn Taze configuration best practices, which would help you optimize the query runs and get the best throughput out of them. Fourth would be the table level optimizations, where we'll understand what kind of tables would be uh, should be considered at what time, and what are the scenarios, what are the options that you can take up regarding that. And the fifth topic is, anyways, general suggestions and troubleshooting, how to troubleshoot as well. We'll pick up around Pulse, how to use Pulse for that as well. So that is the agenda for today. So diving in, the first topic is Hive query execution flow. So as you can see on the screen, this is the data flow where the Hive clients refer to all the clients that connect to Hive. The Hive clients always connect to Hive server 2. It could be a JDBC based client, most commonly Beeline, which is shipped along with the Hive installation. It could be an ODBC client. It could be web UIs. It could be Hive CLI as well. Hive CLI does not connect to Hive server 2, but rather connects to Hive Metastore, but it's already deprecated. So we'll not be focusing on that. So second service here is Hive Server 2. Hive Server 2 is a service which basically manages the client connections. It acts as a thrift to manage those connections. Along with that, it also makes sure of authentication authorization. It also is responsible for query compilation, parsing, and all those stuff. And also, it actually requests the launching of the job at the yarn level. Now, Hive Server 2 also communicates with the Hive Metastore. Hive Metastore is a service which is responsible for the metadata of of all the tables that are involved. It it is a service which gives the information back to Hive Server 2 about the details of where the storage of uh, uh, all the tables are, where the columns, the partitions, all this information, the metadata about a table store is a responsibility of Hive Metastore to provide Hive Server 2 to generate an execution plan. In the backend, Hive Metastore makes use of a backend database. It could be Oracle, MySQL, Postgre, any of the RDBMS, which stores the metadata tables, which has, as I said, the information about the metadata of Hive tables and databases involved. Now, once the Hive execution plan is generated on the Hive Server 2 side, it requests to run a yarn application to resource manager, which in turn starts a Thais application master on it, and different containers spin up on the yarn front to execute the query. Once that query execution completes, the Thais AM sends back the results to Hive Server 2, and Hive Server 2 passes along the information back to the Hive clients. So that is how the whole query execution flow works from the Hive side, and specifically for Thais. Coming to the next topic, query resource management. This is the topic which deals with so basically, first of all, we'll focus on why to use Thais rather than MR engine, which is the most common engine. We do have an option to use Spark as well, but that is not extensively used within Hive context. Spark is a different service altogether most of the time, but yeah. So we'll focus on Thais benefits of Thais over the other execution engine, which is MR. So it has various benefits which are definitely listed on the screen. I think they are pretty self-explanatory, but it is definitely faster than MapReduce engine, because there are various uh, factors which help in to improve the performance. Uh, DAG-based execution model, it actually is you. It's so the DAG-based model helps generate a better execution plan with the resources that are available. So there's no wastage of resources in case of Thais, uh, which again brings us to the next topic, which is optimized resource usage. It reuses the containers, the applications. So there can be multiple queries which can run within the same application, and then the containers within that application can be reused for various tasks such as mappers or reducers. But that is not the case in MR, where it actually starts up the container on an application for a specific task, and that application or container has to go down after the task completes. Whereas in Thais, the same container can be used for multiple tasks. Initially, it can run multiple mapper tasks, and then in the later stages of the query execution, it can start running the reducer as well. So this removes a lot of overhead of starting new containers or applications and reusing the same resources. These also comes with rich monitoring and debugging options. There are different UIs that you can use to monitor Thais execution. In this case, we'll focus on Pulse as well later on during our troubleshooting part of this webinar. And debugging also is easier when you have output of the query execution generated. For example, if you run a query on Beeline, the progress meter shows how many containers are running for different vertices. So all those things are there. There is also very dynamically involved while query execution, where it actually changes the type of joins, it changes the execution plan on the fly based on the resource available. It can scale up the resource utilization and scale down this is resource utilization depending on the resource availability on the yarn side, so giving you the best of both worlds. And obviously it is really compatible with yarn. So these are different basic benefits of using Thais, which will again come to our next point where we can manage query resource using Thais options. So The main thing to manage query resources for yarn resources for a query run is to manage the number of mappers and reducers. Basically, we'll come to sizing of the mappers and reducers later on, but uh, in this section, we'll focus on how to manage the number of mapper tasks per mapper vertex, and reducer tasks per reducer vertex. So we should focus on phase grouping, min size and max size to govern the number of uh, mapper tasks that are generated. Uh, as a failsafe, you can definitely use phase grouping split count, which will where you can set a number for the number of mapper tasks that needs to start for each and every mapper vertex. But it is generally not recommended. It is not the best practice to do so. There might be scenarios where you physically or where you forcefully want to change the number of mapper tasks. In that scenario, you can use this phase grouping split count property, but the focus should be using min size and max size, which governs the split size generated for different mapper tasks, thus governing the number of mappers that are starting. Same goes with the reducer as well. The Hive exec reducer bytes per reducer is the property which will govern the number of reducers starting for individual reducer vertex. Same thing can be done there as well by changing the value for this bytes per reducer. You can change the number of reducers. Now, again, Hive exec reducer max is also a property which limits the number of reducers that can start for an individual reducer vertex. Just note this is for individual reducer vertex, not for the whole query. uh, so if there are three reducer vertex and the reducer max is set to 1,000, at max it can run 3,000 reducer tasks. So just keep that in mind as well. Now there are other ways as well where you can specify the reducer count as well, specifying the number of reducer tasks starting for individual reducer vertex, but that is not a recommended way. Rather, use bytes per reducer property to govern the number of reducers. We'll talk about this further on as well about the reducer tasks. Okay, so next topic is Hive Yarn Tez configuration best practices. In this section, we'll deal with the major configuration properties that you can take up to get the optimal query run as well as throughput and resource utilization on the yarn side as well. So there are various configuration that can be considered as industry-wide standards. So we will take up all this individual. So I have categorized all these configuration in different ways that are listed there on your screen. Uh, so we'll focus on each section at a time. So first is right size containers. In case of Tez, you do not govern mapper container size and reducer container size individually. It is just one container. As I said earlier, in Tez, you can reuse a single container. It can start a mapper task earlier and then the reducer task. So there is no differentiation between a mapper container or a reducer container. So there's just one property, which is Hive Tez container size. Usually it is set to 4 gigs, which is 4096. I would rather keep the size low to give enough resources for the containers, because we cannot change the vCores for an individual container. It will always start with one vCore. So if your jobs are CPU intensive, you can reduce the size of the containers, giving more CPUs for the smaller chunk of data. But 4 GBs is the standard. Unless you face out of memory issues, you should avoid setting it to a very high value, where I have seen people using 32 gigs, 16 gigs, and all those values for a container size. But those are the scenarios where you have blob data types or complex data types, which usually is not the case. So 4 gigs or 8 gigs is at max the best practice that should be taken up. So there is another property which is Hive Tez Java Ops. This is one property which I have seen the being used in not the optimal way quite a bit. So as I've suggested, this property should not be changed from the default value. I have seen people updating Java ops with the XMX configuration for the container size. I think that should be avoided because you have to keep in mind whenever you change the container size, you have to remember to change this property as well if this is hard coded. I would rather not set it at all, and by default 80% of the container size is allocated as the XMX value. This percentage can be changed as well for using another property, but I would rather not do it. 80% is the optimal for 80% of the XMX, 80% of the resources as XMX is the optimal for any container. Same goes, there is another property which can also govern the size of a container from the Tez front, Tez task reducer memory MB, but Hive Tez container size takes the preference, and I would rather not change anything from the Tez task resource memory MB side. I'll focus on Hive Tez container size only because it takes the preference. Now, talking about the same kind of configuration for Tez AM, that is application master. Tez AM resource memory MB is the property. Usually it is 2 gigs, and I think 2 gigs is more than enough to handle most queries, even the complex queries. But sometimes we do see out of memory on the AM side. In those scenarios, this can be increased, but 2 GBs is more than enough for, I would say, 99% of the scenarios. Same goes here as well. Do not update the Java ops property. By default, 80% is taken up as the XMX. And vCore configuration, as I said earlier, even for task or AM does not work in Tez because by default, each container will start with one vCore always. If you want to manipulate the vCores, you would have to manipulate it using the container size, where you reduce the container size, giving more vCores to the with less amount of memory. Sorry, with same amount of memory, it will increase the vCores if you keep the container size as low, and if you keep the container size as high, it will assign less vCores because the size of the container is more, and one vCore will be assigned to it. So yeah, even though the properties are available for vCores, they do not have any effect. Now, another part of query optimization from the Tez side is enable dynamic DAG optimizations. There are a lot of properties in this section. I would not cover all of them, but these are the two most commonly used and also most commonly edited by the developers or admins. So I'll focus on these two. So Hive Tez dynamic partition pruning, it should be set to true. It avoids fetching all the unwanted partitions as well while going through the data. It filters out all the required partitions only, and it fetches only those specific partitions. So in this case, it was really helpful in when you have filters and all those things applied on the query. Rather than fetching all the partitions, it will fetch only specific partitions. uh, other property is Hive exec dynamic partition mode set to non-strict. This lets the user to load partitions without specifying the exact detail in the inside query. For example, if it is set to strict, you need to specify the exact partition name in the insert query to load the data to it. But if it is set to non-strict, you can just use a select query, and based on the data value for the partition column, it will create columns dynamically and load the data to it. So yeah, these are the two properties that you need to focus on this. Uh, we have talked about this scenario earlier in our webinar where I have detailed out the benefits of reuse of these sessions. So as I suggested, yarn applications, yarn Tez applications are reused to run multiple queries, which are numbered as individual DAGs within the queries. So for example, if you open a yarn application logs for a Tez application, you will find the sys logs for individual DAGs there. Individual DAG is nothing but an individual query that is run within that same yarn application ID. You can actually see this when you open a beeline session, start a query. It will start with an application ID, let's say 0001 at the end. And once the query completes and you run another query, it will reuse the same application ID, which is 0001, rather than creating a new application. This is how it saves the time to start the new application and is much quicker compared to MR. Now there is another property which is high server to Tez session per default queue. It specifies the number of yarn application that keeps on running in the queue to avoid the launching of the container in the first attempt as well. As I said earlier, when you open a beeline prompt and you run a first query, it waits for the yarn application to come up in the first query run, and then when the application is up, the query runs in it, and then it does not go down. It waits for the second query to come up. So the launch time of the first query cannot be avoided in this scenario. But if this Tez session, Hive server to Tez session per default queue is set to one or more, there would be all those individual application IDs already running within that queue, which would be waiting at any point in time to get a query assigned to them, irrespective of whether you have beeline open or not. So you can set this property to run multiple applications within the queue. And if you have default queue, three default queues listed using another property, and you have set, let's say, the default queue sessions per default queue property value to 5, there'll be 15 applications running at a time at any point in time, even though there's nothing running on the Hive side. It will keep on waiting for any query to be submitted to them. And if it is set to one, there'll be three applications running if you have three default queues listed. Now, this you need to be careful with this property as well, because this this can lead to issues on the Hive server 2 startup time. So if you have any issue on your yarn side and you try to restart your Hive server 2 with this property set to one, at least one, then Hive server 2 makes sure that the yarn application comes up. If a yarn application is not able to start on the or start due to XYZ reason on the yarn side, the Hive server 2 also will not start. So be very careful with this property as well. But yeah, if you have a lot of jobs running and there is a way to avoid the launch time overhead as well using this property. Another one is one of the options to optimize the query run is definitely managing the small files. Now, small files issue is nothing new for any Hadoop user or any Hadoop admin or any Hadoop developer. This is the most common issue on the Hadoop side, and this is the very common issue on the Hive side as well. There are few ways to manage it. As mentioned on the screen, uh, one way to manage is to manage the number of reducer tasks while inserting the data. Uh, Rest assured, we are talking about non-bucketed table here. In case of bucketed table, the number of files is already set. But in case of non-bucketed table, whenever you are loading the data inside in a table, uh, it will depend on the number of reducer tasks, the last reducer vertex tasks. Uh, it will depend on those number of tasks of how many files are created on the HDFS side for that specific table. Now, if there are 10 reducer tasks running in the last vertex while loading the data into the table, you will see 10 files created on the storage side or on the file system side. So you can manage the number of files using the number of reducer tasks, and I have already spoken about how to manage the number of reducers. Other way to do is, which is very common, is to have merge properties set in place. The Hive merge properties are the properties which will start a separate job at the end of the insert yarn job. So it will start a separate file merge task at the end with different number of containers. Uh, Based on the number of small files generated. So this is a standard way to manage the small files, where it will merge any number of small files at the end of the insert. It will take a little while extra to run that insert job, but it will make sure that there are no small files left behind, and it will merge all those small files to a greater file size. And these are the properties that can be used to manage it. Join strategies is another way to manage the queries. One way to manage the join is to make sure that Hive auto convert join is set to true. It makes sure that the joins, whenever possible, are converted to in-memory joins, and are not because in-memory joins are much faster compared to uh, other joins, which needs the data to be spilled over to the disk. We also use CBO, which is cost-based optimizer, to generate optimal execution plans using these join strategies. Another way to do it is to enable vectorization as well. Vectorization makes sure that the data is processed in batches rather than one record at a time. Uh, Other thing to keep in mind regarding join strategies is to keep the smaller table on the left hand side to make sure that it is loaded completely in memory, which will make your joins or your general queries with joins much faster. And the last one is using proper yarn queues. Make sure you have enough resources available to run the job. uh it is pretty self-explanatory, so yeah. Now comes the topic of table level optimizations. Again, there are various ways to do it. As we can see, I have categorized them in 6 basic topics, uh, and we'll talk about them going further. First one is, again, as it is self-explanatory, choosing correct file format, where you can choose ORC or Parquet format. These are the most commonly used Hive file formats, and I would rather you use ORC format because it is best optimized for days and for CBO related query execution plan generation. Now, why ORC is best suited for Thales? Because it has a lot of stats already collected at the ORC file level, which would help the CBO to generate an optimal execution plan. And also, asset tables are restricted to ORC file format alone. So I would rather you use ORC, which is the best optimized. There can be certain scenarios where you have to use other file formats, but as I said, this is a general best practice. So use ORC wherever possible. Uh, Next topic is when and where to use asset tables, and unknowingly not to use asset tables in the current versions of Hive, which is available with ODP. So latest versions of Hive have a restriction on the managed tables, which are all transactional tables. Transactional tables are nothing but asset tables, which allows updates, deletes, absurd queries, all these operations. But it comes with its own overhead, where the sessions, the locks, and all those things need to be managed along with the compactions as well. Compaction is merging of updates, deletes, and all those things to the base file or directory on the table side of this is on the storage level. But just need to you need to make sure that if you are not concerned about whether table is an ACID or not, make sure you create an external table rather than a managed table by default, because by default it will be generated as ACID. And if you do not specifically need ACID properties for your table or ACID operations for your table, it will create an overhead rather than helping you out. So make sure you are aware of this. Create external tables. You can have external tables which will mimic the legacy managed table behavior, where you will, if you drop the table, it will drop the data as well. You can have that scenario in an external table as well in later versions of Hive. In the latest versions of Hive, you can have purge enabled in that case, where if you drop an external table, the data will also be dropped. So it will behave as legacy managed tables. But if you specifically do not specify by default whether it is an external table, it will create a managed table, and a managed table would be an asset table which will add to the overhead. So yeah, you need to be aware of this. Next part is compression. Compression uh, is a really good topic to take up, where it will improve your space utilization on the file storage side, as well as it will reduce the amount of data traveling over the network. Uh, there are these are the two basic benefits of using compression with Hive. So there are different compressions available for ORC file format. Zlib, Snappy, LZO compressions are available. There are different compressions available for different file formats, but for ORC these three are available. You can use any of these while creating a table. Also, there are options to make sure that whenever data travels over the network, be it within a yarn application where the data is shuffled over from one container to another, from one mapper to another mapper, or from mapper to reducer, or from one reducer to another reducer, uh, it is compressed. So you can use this Hive exec compress intermediate properties at to true, which will compress. It will add a little bit of overhead for compression and decompression, but if you are dealing with a lot of data, it will ultimately be beneficial. Another property is Hive exec compress output. It will compress the data that is generated as an output of a query of a yarn job, and is presented to the Hive clients. So while getting the data from last reducer container to your Hive client, the data will be compressed. So again, it can be enabled or disabled using true and false. Hive exec compress out. So all these properties help with data extraction and obviously query performance if compression is enabled. Also helps with resource utilization from the space side of things. Next is statistics collection. Now, this is a very important point when we are dealing with TAs and CBO. Statistics collection is really important because CBO makes decisions based on the statistics available for any table, partition, or even columns. Uh, More the statistics available, a better informed decision or execution plan will be generated by the CBO or TAs. So more the number of more the metrics are available for all the tables, partitions, and even columns, better would be the execution plan generated, and better would be the resource utilization from the yarn side as well. By default, table and partition level statistics are collected whenever data is inserted to any table or partition. This can be enabled and disabled but by default it is enabled. uh, and the statistics are always collected whenever you insert data to a table or partition. Now, column level statistics can also be enabled or disabled, and they can be collected manually. Same goes for table and partition level statistics as well. We can use analyze table commands to collect the statistics, which would always help. So whenever you have a query which is performing badly, the first thing that you need to do is collect statistics, at least if not column level statistics, collect statistics for table or partition level for all the tables involved in that query, and that should definitely be helpful for the initial stages. it sometimes fix the issue altogether as well, because the execution plan generated is much better. Again, partitioning is also a really important topic to optimize the table performance. You need to choose your partition columns really wisely, where you need to make sure that the column, the partitions that are chosen for any table are distributing the data properly. There are no skews in them, and the granularity is also not too small. So over partitioning can also lead to issues of small files, as we know that is a problem. And also, if you have too many partitions within the table becomes really slow to access, where because it has to fetch a lot of metadata from the Hive metastore. So you need to be very vigilant of the fact what partition columns are chosen and what is the granularity of those partitions, and make sure you have better strategies in place to have a better partition table. Bucketing is also one of the factors which help or degrade the performance. More often than not, it degrades. That is why I personally always suggest to disable bucketing if not needed. But yeah, bucketing restricts the number of files within a table or a partition. It's a dual-edged sword, where sometimes it helps and sometimes it is the major factor for a performance impact. I would rather avoid bucketing, because you can manage the number of files using reducer count, as we discussed earlier, and the Tez merge properties. So you can definitely do that. You can manage the number of files rather than using bucketing. Okay, this brings us to the conclusion of the table level optimizations. The next topic is general suggestions and troubleshooting. Now, in general suggestions, I am pretty sure any SQL developer would be aware of these things, but these suggestions play a very vital role in case of Hive. Uh, Use filters whenever possible, because filtering out the unwanted data can reduce the load or the data that is traveling on the network by quite a bit. For example, if you filter out a query based on a partition column, it will, as we suggested earlier, partition pruning, it will fetch only the specific partitions rather than fetching the data for all the partitions. So it considerably reduces the data that needs to be analyzed or to generate a query output. Also, avoid running select star queries. It involves complete data fetch. And most times, if you run a select star on a table without filters or anything, it will not generate a yarn application. And if a yarn application is not generated, all the data flows through Hive server 2, which can lead to the stability issues of the Hive server 2 as well. If the data that is being fetched is too huge, it can lead to out of memory issues on the Hive server 2 side. Hive server 2 can go unresponsive. So service level issues can also be seen. So select star queries should be avoided. Try to select specific columns wherever which are needed for the output generation, and add filters whenever possible. Now we have discussed the next point, we have discussed quite a little bit earlier as well. These are focused with the join conditions, right? Always use smaller tables on the left side of the join to make sure that they are in memory, and the execution is much faster rather than spilling the data over to the disk. Use map joins wherever possible. It is again connected to the same thing. Avoid setting reducer counts and mapper counts. I have also discussed this earlier. Avoid setting hard-coded reducer and mapper task counts, or let Tez decide based on CBO and statistics the number of mapper tasks and reducer tasks that are needed. It will give you a better performance. Last point is use materialized views wherever possible. It's a new concept. Materialized views are used for any logic or any query that you reuse quite a bit, or subqueries that you use quite a bit. It can be refreshed manually and automatically as well. The data can be refreshed. It is different from normal view, where it actually stores the data on the disk, and it is just fetch from the disk. rather than just a logical view. It is a physical view where it actually stores the data separately as well. So it can quite boost your query performance quite a bit if you have repeated queries. Troubleshooting part. You need to be vigilant of the Hive query execution performance and troubleshooting, because it's a dynamic thing, right? Where the size of the data constantly changes. There can be skews in the partitions. There can be all those different things that can arise dynamically, or that can arise in a table. So you have to be constantly vigilant and evaluate the query regularly. You can use explain plans to check how much data is being fetched for the query execution and how the query execution plan is being generated. You can definitely make use of explain query output for that. Um, you should definitely monitor the resource utilization from the RM side, as well as the, as I said earlier, beeline output, where it talks about how many tasks are being used for any query execution. Keep monitoring that. There can be certain queries which can hog up all the resources from the yarn queue, which can affect other jobs that are running in the queue. So you have to be vigilant about that. Also learn how to go through the yarn application logs and High Server 2 logs, how to correlate the yarn application ID with the query that you run, how to identify query IDs, how to identify DAG IDs. That will be a good option to go for individual to troubleshoot individual queries. You need to go through Hive Server True logs. You need to identify individual query details within the yarn application logs. We have talked about this earlier in the call. And obviously, we have our own data observability tool, Pulse, which can be used to do all these things. So as you see on the screen, Pulse can be used to troubleshoot various aspects of Hive. In this snapshot, you have the queue level resource utilization from the yarn side, which is for Tez specific jobs. It is under the Tez section of the Pulse. So it talks about how many users are using Tez jobs, how many queries are running, average CPU allocated, and all those information is right there to be used. How many vcores are used, memory usage, query execution count, how many queries have executed, average query time, and all those information can be gathered. So it will give you a bird's eye view about the resource utilization from the yarn side and Tez side specifically. Next part is query level troubleshooting within Pulse. In this example, we are seeing a query execution. Specifically, you can see the query as well here mentioned in this section. In this scenario, in this specific example, the query failed. It talks about all the query trends here as well in the past, whether the query has successfully completed or not, whether it has failed, and all those things. You have the query trends scenario as well. As well as if you go down this section on Pulse side, you will see a lot of information which is evident here. So you have individual stats for reducers and mappers. You have how many seconds, or what is the duration of the mapper vertex, reducer vertex, what are the total tasks that ran for individual vertex, how many failed attempts were there, and all those things. So it talks about, gives you the an overall UI based uh, details of individual query vertex, as well as the tasks running for it, time taken by individual tasks and vertices, and all those things. You can definitely explore it further. You can also view the query execution plan. It's a visualized plan that you can view from Pulse rather than using explain query output, which will give you a subjective output of the query execution plan. You need to be experienced on how to analyze that output. But if you are novice, or if you want to have a visual representation of the query, this is a simple query. That is why you have a simple execution plan. But if in case of complex query, this diagram of the execution plan helps quite a bit to understand where the bottlenecks are, how much data is flowing through each and every vertex, and what all connections are being made, and all those things, whether it's vectorized or not, and all those things. So you will get a lot of information in this in this UI based execution plan using Pulse. So this brings us to the conclusion of our webinar today, and this wraps up our webinar today as well. You can post your questions and concerns on the chat if you have any, and if not, we can conclude this meeting. Okay, let's wrap this up. I really appreciate your time and time on this, and yeah, let's work together to improve Hive and query performance further in future. uh, Thank you for your time. Have a great one. Bye bye.